But yeah, my name is Jon, and I work at Block, and I focus on our Kubernetes platform, and I really want to talk about SLOs. So if you do not recognize Block, you might recognize some of the companies that make it up: Cash App, Square, Afterpay, Tidal. We are one big happy family building a bunch of financial tools and music tools and deploying a lot of things onto Kubernetes. At Block, like I said, big happy family, building all these engineering tools. We're running about 50 plus clusters from different cloud providers: AWS, GCP, on-prem. And we have a good number of engineers touching our platform in different ways, a good number of services. And so we are doing a lot of different things in Kubernetes. And at a certain point, we started getting some questions about how do we express the uptime of these Kubernetes clusters and this platform to our internal users. If you deploy applications onto Kubernetes, you write code, all that fun stuff, can you just raise your hand so I can get a feel? Okay, cool. And then even if you're a manager of one of those teams, that's awesome. And if you are a Kubernetes administrator, okay, perfect. So not going to call on anyone else this entire talk, but it helps to contextualize some things. And we're really going to jump into defining what a user journey is. So starting with this definition at the top, and a user journey is a structured representation of an internal user's interactions with the platform. We'll bring this back a little bit later on, but there's a little thing that I have to get super specific on, which is that normally in an application, or like for a service for your company, you've got external users. I'm an artist, and this is Cash App, sending money to people sending money. And then you've got product engineers building Cash App, building whatever your service is. And there's an agreement where the engineers are trying to build something that the customers expect, those external users. It should send money to you whenever I use Cash App. And sometimes that's represented as a status page that like, hey, everything's working properly. But at the platform engineering level where I sit, we really don't get to talk much to those external users. We love them, they're great, but we don't interact directly with them. So this talk is not about the external users. This is talking about that group one, the product engineers who are building things that our users are using so that we can help them in understanding Kubernetes. So product engineers, platform engineers, we want to make the product engineers' lives easier by making sure that they understand what's going on with their services. And so that's where user journeys come in. And these are the two main things that I want everyone to take away from this talk. I want you to have a strategy for user journey testing inside of your platforms. And then I also want you to be able to visualize this and represent it back to your internal users. Because, well, actually, I really want platform admins to be excited to add tests to their clusters. I know that's a huge ask, but I think it's possible. Because if we do this right, we can eliminate one of the most frustrating questions that comes up in Slack channels or in tickets. Hey, is something broken? Enter whatever it might be. And so we're going to journey into user journeys. No one liked that. All right. We're getting into this. When we first started diving into everything, we were asking two main questions. When we change something, how do we ensure that it's not broken? And whenever there's time in between our changes, how do we know that it stays in a good state? And by changes, I really mean everything like installing a new tool in a cluster, upgrading an existing tool, changing your VPC configuration if you're in AWS, just anything that could affect your system. And this illustrated two main things. We're asking time-based questions. And that tells us that we need to, one, run tests whenever we take action, and then two, continue running these tests on an interval to ensure that we're good. Not to give too many things away, but SLOs. That's how we're going to build those. The next question is actually a really fun one. What is not broken? And not broken for us here means from the end user's perspective. I love this example. So a coffee cup with a broken handle It passes the unit test of, hey, I hold hot liquid. That user journey is not going to be fun for anyone. I got some chuckles from my coworkers. And so really, like I might ask you in a Kubernetes context, if I scale a service, if the replica count on a deployment changes, was that a successful user journey if no pods ever came up? No, it was actually the pods coming up and completing the entire journey from what our user expected. And so we're going to have a little scenario that we're going to use as an example in this talk. And it's just going to say that the platform that we all here are building together supports blue-green deployments. So from that group one perspective, you deploy applications into Kubernetes, you write all the fun code, you have your namespace, your service is running in there, you have a deployment, it's got some pods. You go, you deploy. We're doing the blue-green, so those new sets of pods start to come up. Once they come live, we've got our old code, the blue pods, our new code, the green pods, and everything's running. The user looks at all the signals coming from the system and says, green's so good to go, let's promote that. They promote it, the old pods exit, we've now got these, the green pods running, everything's great. They're happy, right? Like that was blue-green, we got it. They come back the next day, new feature to release. They go back, they find their app, they're in their namespace, they trigger deploy, they wait, no pods come up. They cry. Not as good as a happy face. And so this kind of kicks off, this might kick off some questions in your help channels saying, hey, our deploy is broken from your users. And then your platform engineers come in, they say, oh, is this just that app? Or is it every app? And when did this break? And so it begs the question, should developers have to identify a problem in your system before a platform engineer knows there's a problem? Ideally, most of us will say no to that question. And so that's really what we are getting at here. Because whenever we have Kubernetes clusters and we have that service namespace, it's the top of the iceberg. But the admins here know that there's a whole bunch of stuff below there. Operators, controllers, internal tools, just so much going on that we are obfuscating from the end user, our internal developer, because we want to make their lives easier, right? And so what we're doing is we're talking about testing everything below the water level on that iceberg. So let's actually get to the fun part of this talk, which is making a user journey. And we're going to peel back the layers a little bit or submerge a bit and say that, hey, so in our Kubernetes cluster, we have what the user saw before, their namespace, but behind the scenes, there's probably a controller managing blue-green deployments. And so that controller is watching that deployment, and whenever someone comes in and initiates a deploy, we get some new pods that come up, we check the status of the existing pods, and then we create a replica set. We start to wait for those new pods to come in. They come in, and we're like, all right, great, we're good to go. And maybe your controller's advanced enough to spin up a job pod to run some tests against those new pods and say, hey, does it all work? I see some people nodding, so like, yeah, we're used to this. That's all sending signals back to those internal application engineers, and they get to make a promotion decision. It happens. We go forward, the old pods scale down, and then that controller goes back into that watch loop and that monitoring of the existing pods, waiting for the next deploy. And we're happy because, hey, we did it all right. So go back to this question. I just enumerated every step that our controller is doing at a high level for this talk. So can't we test this? Can't we make sure that this keeps happening successfully so that users don't have to self-report a problem? And so coming back to it all, told you I wanted these to be the two takeaways. Well, now we're going to get into the first. So, chainsaw. We're going to get into that tool in a second, but bringing back this definition, a structured representation of how internal users interact with our platform. Structure is what we want. That's what we crave as engineers, generally. And so this is a very quick introduction to Chainsaw, which is a declarative end-to-end testing tool that is under the Kubernetes project, which is a policy engine in Kubernetes for enforcing that everything works in your cluster and is standard the way you want it. You don't have to take a picture of these slides because this is literally the quick start. So just to walk through this real fast, Chainsaw, it's YAML. It runs from top to bottom. And so in this one, the example on their page is saying, hey, if I have a config map defined in a file and I apply it to a cluster, then I should be able to assert that that config map exists. That's high-level Chainsaw. So this slide will also come up a little bit later. You don't have to scan this one. But there's a demo repo where we've got everything we're about to walk through. This is my way of saying prepare for YAML. I hope everyone brought their glasses. But we'll bring this up again. I just have to, in these slides, lie to you a little bit for some storytelling purposes. We are going to simplify the slides in the next bit and say that a Kubernetes deployment can actually natively support blue-green. In this demo repo that I showed, everything's correct, and that lie is not there. But for walking through this, need to simplify. So this is going to be our actual user journey. We're going back to that rollout controller example. We're going to execute a test in the rollout controller namespace for this thing that the platform teams manage. So it's my job to upgrade our controller. I come in and I initialize an upgrade. A job pod spins up, and this is going to be what actually executes Chainsaw, that thing that we had a 5-second intro to that y'all will all love by the end of this talk. And when Chainsaw runs, it's going to provision just some test deployment in that namespace. This is what that YAML looks like for the test in the demo repo. There's a resources file, couldn't enumerate everything here for readability, but this is the actual step. So that deployment spins up some pods, and Chainsaw is going to wait and say, hey, did we get into a good state? That's what the YAML looks like for a wait statement. Anyone that's very familiar with Kubernetes is going to see that and be like, ah, OK, looks pretty Kubernetes kubectl centric. Then we're going to, remember, we're going through a user flow, so we are going to update the image on that deployment. And Chainsaw is going to do that by patching. And so we're going to just perform a patch against that deployment and replicate, oh, hey, we released some code. Anyone who's familiar with the Argo project might recognize some of the things that we're actually testing behind the scenes, and that's what's in the demo repo. But again, a kubectl patch. So we've done that. The new pods start to come up. Everything's looking good. It's green. And in this state, we're waiting for the pause state. Hey, everything came up. So then we decide to promote. I wanted to show this slide because Chainsaw also allows you to execute arbitrary tools inside of your job container as long as they are present. So load those in, and you can perform a promotion or call any service you might need. And then we're going to do the same steps. We're going to wait for those pods to drain out. Again, another wait statement. Finally, and I wanted to show this one, we can assert a certain state in our clusters. So there is an assert statement in Chainsaw, and so you might be able to say, like, hey, I want to make sure that pod count got to here. I want to check the presence of some resource. Finally, the worst part about this whole presentation is actually not cleaning up the resources, because Chainsaw does do that for you. So in this whole flow, Chainsaw has been executing, and at the end, it says, I know everything that I made, and I will tear that down gracefully for you. By the end of this, your job test pod exits successfully. Everyone's happy. So with Chainsaw, we enumerated a structured representation of that whole flow and shipped it into our cluster and said, great, we know blue-green deployments are working. And I told you we wanted to do this when we install or upgrade and then continue it on some interval. And so back on this slide, everyone's probably like, you got your colors wrong on those two numbers. Why is one of them pink? That is meant to represent the only human interaction in this whole flow. How we did that is with Helm. And for anyone not familiar with Helm, it's a very common package manager for Kubernetes. A lot of open source tools package their tool in a Helm chart so that anyone can install it in their cluster. And Helm has hooks. So to achieve that install or upgrade time test, we hook that job pod creation into the Helm lifecycle and launch it whenever we perform an action. Everything else is then automated. And so we have that user install or upgrade time, or the platform admin. Interval. Has anyone heard of, well, I can't ask that. So KuberHealthy is a really cool tool in the ecosystem. And KuberHealthy is a synthetic test orchestrator. And what it allows you to do is that, I took this GIF from their docs, but it shows you that very first step is that if you inject a KuberHealthy check resource into your cluster, it will then run whatever check you define, which is just a pod spec, on some cron. That then gets reported back to the operator in your cluster, and then you can operate off the signals that come out of there. And so what we do whenever we do any of these upgrades of these resources is that we also drop a KuberHealthy check into the cluster. And that ends up making our lifecycle look like this. Whenever we install or upgrade anything, we get the Helm hook test. In between each upgrade, we're running KuberHealthy on some cron. And that's going to fill in those gaps of any configuration that came from outside of the system, but is directly affecting the system. And so, your tests whenever you're installing and on a cron. And now, we just have to deal with the hardest part, communicating back to the users. But, and so that's one of the things that we listed, so we're going to tackle that now. And we didn't get to dive too much into this with KuberHealthy, but KuberHealthy exports Prometheus-style metrics. I highlighted the most important ones right here that we build a lot of our SLOs off of, which is just a gauge. 1 is passing, 0 is failing, and that's a pretty simple signal that you can use to start building your SLO. So yeah, maybe the most boring slide in all this is you configure that integration, you ship it up, you have this metric, you build an SLO. That was a little boring, so we're going to fake some broken tests in here. And this is the real foundation of everything that we do. At Block, we run 50-plus clusters. And so what we want to do is aggregate that user journey by cluster and have a general SLO that might inform users, hey, something's broken in our system, but also be able to, at the platform level, identify you have a broken journey in a specific cluster. We need an admin in there to start looking at it. And so we take this one step further. This is a fake dashboard because I can't really copy our internal ones, but you take those SLOs and you put them on a dashboard. You then explain what that journey might mean to a user. So if the API servers are having issues with reads, right, your kubectl commands might not work. Some users that use kubectl might be affected. Blue-green deploys. Anything like that. Monitors for the platform teams for burn rate. Huge. Really helpful in identifying hotspots in your system. And this is where you can kind of have like a real-time dashboard in a sense, because you can do those, the global time check whenever you're building those SLO visualizations. And so if your dashboard time is set to the last hour, you see the last hour performance. Your real time in this is dependent upon that KuberHealthy interval. So the smaller that interval gets, if you can run these tests every 5 minutes, every 10 minutes, every 15 minutes, then you start to narrow down your real-time window and make things and make these visualizations a lot more actionable for platform teams. Okay, so I know we're just like going through a lot of slides here, but just wanted to walk down the checklist of things for you. We said we wanted structured tests to represent the interactions that users are taking in our system. Chainsaw's got us covered on that. We said we wanted to trigger tests at install and upgrade time. Helm is our package manager and those hooks. We said we want to do continuous testing on an interval. For us, that's KuberHealthy. And then we wanted to communicate back to app engineers. Surprise, we're at a Datadog conference. SLOs and Datadog. And so that really covers the two main things that I wanted everyone to take away. But we're not totally done. Just have to say really what we like, which is that for platform admins, This is a very Kubernetes native, Chainsaw itself is a very Kubernetes native tool. It doesn't really require you to learn any other languages, any other frameworks. It is easy to pick up for admins. I know because my entire team was like, oh yeah, that makes sense. Standardized metrics for that reporting. Oftentimes, whenever you are building these tools and you have different tests running in different namespaces and whatnot, you might get different styles of metrics coming back. Oops. But with everything centralized through Kubernetes, you get a single source of truth. And then this is the part that we didn't cover because it's a lot of content, but there are some additional things in the FAQ, some additional slides after this that I can cover. The real trick for us in this with our Helm charts is that we are putting these tests right next to the actual chart that we are deploying. And so happy to dig into this more, but for us, whenever we deploy the actual rollouts controller managing our blue-green deployments, these tests live right next to it. This is all in the demo repo as an example to show how it all gets wired together. But the big thing is that it allows us to ship with confidence because we are doing both the testing and the actual deployment together in the same spot. Tests are tightly versioned with your actual controllers that you're deploying or your tools. And that's huge for rollback and understanding what's going on in your system. This is a GIF of the actual demo repo, and Chainsaw runs locally. And so that's another huge thing. It works off your kube context, so you can write these tests, assert them against an actual live running cluster, be it local or in the cloud or somewhere, and you will just see that you can iterate very quickly as you build out these tests. And so the effort to get a test into your chart, into your cluster, very minimal. But there is some friction. This whole methodology relies on the fact that if you don't have a pod, you don't have a test for those cron tests. And so if your cluster is severely degraded, you're going to need to monitor for a no data situation. Kubernetes, love it. Super simple, very direct. It's not an entire workflow orchestrator. And that means that the scope of what you're testing is really a single Chainsaw test file. And while it is super powerful and simple, it can't do everything. I would suggest picking up a different workflow orchestrator because at the end of the day, it's still a container, and you can ship that around and put it in any tool that you might want to use. I said the metrics were really powerful because they're unified, but they're also not super granular. That's my one gripe. This is solvable because Chainsaw itself can output a test report that will tell you very millisecond-based timing so that you can submit your own custom metrics outside of Kubernetes. But it's a little bit of a hoop to jump through. And finally, going back to that whole multi-cluster story that we have, Block aspires for cellular architecture in all of our clusters, but I would not use this system for doing multi-cluster based tests, but it is amazing at identifying a regression in a single cell in all of your clusters. And so that's where we find the most value is being able to say okay, deploys in this cluster are not working, why? And that's where we know to dedicate engineering effort. And yeah, that's really it. I just want to say thanks. And the demo repo is there. It contains no lies. But yeah, feel free to submit any issues, ask any questions on there. And otherwise, happy to answer any other questions. Cool.
We got microphones in these two aisles. If you have a question, please come up to the microphone. I'm curious, Jon, what are you going to do next? It looks like you've pretty much covered a lot of this need. What is the future step that you're looking forward to?
We probably want to adopt a more robust workflow orchestration system, Argo workflows. I know we kind of alluded to it in the talk, but we are invested in the Argo CD, or the Argo ecosystem. We use Argo CD heavily, Argo rollouts, and so Argo workflows is a natural extension of that, but it would allow us to chain a few of these tests together in different ways.
Hi, thanks. My question, this may be just related to maybe you kind of keeping things simple for the talk, but in your example, you say like, you have this user store, you have the user trying to deploy and it fails in their namespace, and so you have this test running in your rollout namespace.
Yeah.
Isn't there a possible scenario where it still fails in the developer's namespace, but not in your test namespace?
Totally. And so that's one of those things where, you know, the why is it failing? Like, yeah, what if it was a bad release? You know, some of those things you can mitigate for in signals that you have, but what we want to do is provide that front door of saying, well, is it just me and something I might have done as a app developer, or is it the entire system? And so if we provide that dashboard, that SLO, that place where you know, I can find out if it's a me or a system-wide problem, then we can mitigate some of those first steps that a user might take, and they might be able to look more and say like, oh, I need to dig into my logs, I need to dig into my actual application. But you are totally right. It is one of those things where the thing that you are testing in that namespace, you want it to as closely mimic the live services as possible. And so if you're using a service mesh, yeah, maybe you bring Istio into it as well, right? Like, it does further complicate the test, but at least you really know that journey is fulfilled in what I'm testing.
Thanks.
Yeah.
John, this sounds awesome, but it also sounds like a lot of work. Did
Yeah.
you have a way to bundle it so that other people can actually adopt, like other people within Block can adopt it more quickly?
Yeah. Yeah, these are my post-talk slides. At Block, we take the upstream charts and we wrap them in our own versions, in our own charts, so that we can use other tooling to manage versions, all sorts of things. But really, what we've done, and this is all in the demo repo, is that we have a library chart, which is just a set of helper functions that can provision a lot of these testing resources for you, and they know how to interact with this directory structure. So I talked about it before, but like for Argo rollouts, we put a chainsaw test hidden directory in the Argo rollouts chart, but our chainsaw test chart that's in that repo, it knows to look for that directory structure. And we didn't just make this up, we ripped it from the actual Kubernetes open source tests so that we weren't just, you know, following some random standard, adding another one to the list. But this is the pattern that we follow of wrap the open source chart, ingest all of our things in there, because we often find that we're wrapping charts anyways to add additional templates and whatnot. Everyone's got a different workflow, but this one has worked really well for us.
Thank you very much, John. Well done.
Sweet. Thank you.